Hello student, let's try to understand the question number 11. How will you bring the following conversion? They are the very simple student. The question number 1 is there, ethanol to butane student. So the first one we are taking student. So ethanol if you want to do student, this is the CH3, CH2, OH student. And we have to convert into butane, right? So you treat with the PCl3 or SOCl2, right? SOCl2, it will give student CH3, CH2 and Cl. Now if you treat with this one student, this compound CH triple bond CNA, so what will be there student, this is the Cl and Na will be out. So what will be giving is student, this is the CH3, CH2, this is going to be C triple bond CH. Now you can count 1 2 3, this is 4, this is the but, what is there student, 1 ine. The first one is over. Now ethane to bromoethane, ethane to bromoethane. So what the reactions you should follow student to convert the ethane to bromoethane, right? So let us see student the second one, B. Here we are doing a student. So CH3, here we can do student CH3 plus ethane to, this is bromoethene student. You treat with the Br2 student, right, in presence of sunlight student. So it will give the free radical substitution reaction CH3 CH2 Br. Now you treat with the alcoholic KOH student. So it will undergo elimination student, dehydrohalogenation. It will give CH2 double bond CH2 student. Now again you treat with the what student, Br2 in CCl4, Br2 in CCl4. So Br2 in CCl4 student, what it is going to give dear student in the case of this one, dibromoethane. The question is going to be coming, that is CH2, and both the places it will be coming Br. Now you need to treat this with another alcoholic KOH student, alcoholic KOH, but you need to avoid, what you need to avoid, soda might you need not to take student. So minus H2O it will be there student, minus H2O, and this is the minus KBr also there, alcoholic KOH you take. So minus KBr student. So what it is going to happen here, suppose I am taking KBr and we need to take one hydrogen from here. So what it is going to give student, CH2 double bond CH, here is Br student, one bromo ethene student, one bromoethene. Now let us check out the third one student, propene to 1 nitropropane. Next one, third one, propene, PROPENE, propene to 1 nitropropane. So we have to add with the, nitro compound to this student, okay, propene 2. So dear student, here is the, we are taking the propene, CH3 CH double bond CH2, propene. Now you treat with the what student, any of the, suppose I am taking HBr student, but I am taking peroxide. So in case of peroxide, what it is going to give student, CH3, this is CH2, again CH2, here is Br, right? Up now student, this one can be treated with AgNO2. Avoid the KNO2 student, otherwise nitrite will come. So it will be give student CH3 CH2 CH2, what is student, an NO2, 1 2 3, 1 nitropropane. 1 nitropropane. This is. Let us see the fourth one, student. Toluene to benzyl alcohol. Toluene to benzyl alcohol. BEN, very simple, student, benzyl alcohol. This is also very simple. Dear student, this is the toluene, dear student, CH2. You need to CH3. You need to do the Cl2, student, in presence of H2nite. So what it will going to give, student? Substitution reaction. It will give free radical substitution reaction. Now you treat with the NaOH, student. This is the SN reaction. So it will give the student what is benzyl alcohol. This is CH2. Here is the OH, student. This is the benzyl alcohol. Now let us see the next one, student. What is going to be the next one? Here we are having propene to propine. Very simple, student. Propene to propine. Propene to propine. Okay. Dear student, what is the propene? This is the CH3 CH double bond CH2. Now what we need to do, student, first of all you treat with the Br2 in the carbon tetrachloride. So it will give this one, student, di. Here will be the Br CH2. This is again going to be Br. Okay. Now dear student, what we will need to do, that is alcoholic KOH. You take alcoholic KOH and sodamide, student. Otherwise you can directly treat with the alcoholic KOH. So what will be there, student, if you are taking the 2 molecule? So 2 kBr is going to be out, and 2 water molecule also. So it will directly give, that is CH3 C triple bond CH. There is one way more is there, student, that is you take with the alcoholic KOH. So what it is going to result, student? Minus H2O will be there and minus KBr. So it will be CH3 CH. Br is gone, student. CH2 Br. Now NaNH2 you take, student. NaNH2. NaBr will be out, student, and NH3 will be out. So it will be there CH3 C, right, triple bond, student, and CH. So there is 2 methods are there, student. Now let us see the next one, student. What is the next one? Ethanol to ethyl fluoride. So ethanol to ethyl fluoride. Ethanol to ethyl fluoride. Ethyl fluoride. Ethyl fluoride. Ethanol is what is there, student? CH3 CH2 OH, ethanol. Okay. Now student, you treat with the SOCl2. So what you are going to get, student? CH3 CH2 Cl. Now you treat with the AgF, student. So what will be there? This is the Finkelstein reaction. CH3 CH2. This will give, student, what it is going to give, student? CH3 CH2 F, ethyl fluoride. Now let us move out the G number, student. What is the G number? Bromomethane to propanone. Bromomethane to propanone. Bromomethane to propanone. So we are having what, student? Bromomethane to what is there, student? Propanone. CH3 Br there is there, and we need to get propanone, student. So first of all you treat with the KCN, student. Okay. So it will give what, student? CH3CN. Now you treat with the what student? Grignard reagent student, CH3 MgBr. So what it is going to give student? This will going to give intermediate CH3C. Here is CH3. This is double bond N MgBr. Now student, what we can do student? This one, that is HOH. If you are doing student, here is the nitrogen is there, and H plus is also there. So acidic hydrolysis if you are doing student, it will directly give the ketone. This one. Now let us see the next number. What is the next number student? What is there? But 1 in to but 2 in. But 1 into but. What is there student? But 1 in to but 2 in. We are going the upside here, checking but 1 in to but 2 in. Let us see student, but 1 in to but 2 in. How to change the position of double bond student, right? So this is very simple student. We have to apply the Serge rule. So here is CH3, CH2, CH double bond CH2. But 1 in, 2 we have to go to but 2 in. So you treat with the HBr student. MR rule, Markovnikov rule, CH3, CH2, it will be CH, here will be the Br student, this will be CH3. Now dear student, you are treating with the alcoholic KOH. So what is there student? This is the CH3, CH double bond CH, and this is CH3. This is going to be but 2 in. But 2 in. This is. Here is this is the Serge rule student. SAYTZER. This is the called Serge rule. Now we are going to study the I. But 2 in, but 1 into but 2 in. So 1 chlorobutane to octane. This very simple student, just simple the Woods reaction. Okay, 1 chlorobutane to octane. Let us see student, what is the 1 chlorobutane? 1 chlorobutane to what student? Octane. So CH3, CH2, 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 take one more molecule student, CH3, CH2, CH2, Cl student, treating with the 2 molecule of sodium student, it is going to be dry ether student. So in the dry ether minus 2 NaCl will be out student. Now see the product student, CH3, CH2, 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 and finally it will be, so this is the octane dear student. Last one we need to go student, benzene to biphenyl. So simple student, benzene to biphenyl. So benzene easily can be converted into what student? Chlorobenzene. So you see student, this is the benzene. You are treating with the Cl2 in presence of FeCl3. Dear student, what will be the product? Here is the Cl. You take the 2 molecule student, right, and treat with the sodium. This is going to be fatigue reaction. So what it is going to give student? This is the biphenyl. This is our required product student. Thank you very much for watching students.